We will be looking at how the system stores negative numbers for us. All right, that is the topic of this presentation. We have, before we look into that, we need to understand what a transitive law is all about. All right, what it states is if A equal to B and B is equal to C, then we have A equal to C. That is the transitive law. All right. Let's look at this couple of equations. For any positive number we have, if you for any positive number, if you add the negative number of that, we always get a zero, right? So that is very trivial, right? On the other hand, we have, if we take the same number, positive number, and the complement of that number, if you add them up, then you add 1 to it, we get 0. We will see what this is all about. We're going to look into this equation now. All right. Once we know, we are happy with this equation, because this is 0, this is also equivalent to 0, we'll prove that this equation is nothing but is equivalent to this equation. All right. All right. What is 1's complement number is the next question, right? What is 1's complement? In any bit or byte, if you flip the zeros to 1 and the ones to zeros, you get the 1's complement of that number, of a number. All right, that is all about, that is what 1's complement is all about. For instance, if you take this number 0110 in binary, the 1's complement of this number, whatever that number is, right? I'm flipping the 0 to 1 and this 1 to 0, 1 to 0, and 0 to 1. So this is the 1's complement of that number. Let's take another example. 10100 is a binary number. The 1's complement of that number is, I flipped this 0 to 1 and that 1 to 0, so it becomes 10101, the 1 complement. All right. So we have this again, we are here again. That's what 1's complement number is all about. All right. So we have, because this equation is, because this number and the negative number is equal 0, and we have another equation. Okay, this is a second equation. Second equation. We have the number and plus the complement of that number plus 1 equal to 0. So we are going to by transitive law, this n plus minus 1 minus n should be equivalent to that. All right, that's what we do here. Because of transitive law, this is equivalent to 0, this is also equivalent to 0, so those two should be equal. That leaves us, if you shorten that equation, we have negative number is nothing but 1's complement plus number 1 plus add 1. So we will prove that, how that is done. All right. So any negative number is nothing but 1's complement of the positive number, 1's complement of the positive number, right, plus 1. Okay. Let's take the simple example here. Let's take 0110. This is a 4-bit, all right, of 6, positive number 6, it is positive 6. you need to put 1's complement, okay, which is 1 0 0 1. And if you, that's 1's complement, okay. Then we saw in the PowerPoint 1's complement plus 1 becomes a negative of that, right? So go back, and if you add 1 to it, right, then we add them up, right? 1 plus 1 is 2. In binary, it's equivalent to 1 0. All right. So we have 0 and carry 1. Carry 1. All right. So we have 1. I'll put 1 carry. All right. 0 plus 1 is 1. 0 becomes 0 and 1's become 1. So this is the negative number representation of -6. Right? There is a website here. I'll show it to you here. There's a website that talks about. So it's a 2's complement calculator. So we saw -6 representation. We have 4 bits, right? Converted 1 0 1 0 1 0 1 0. We have 4 bits. That's what it's talking about. Let me copy this guy to our PowerPoint. We'll do a couple of examples, all right? Do a couple of examples. Let's take another example here. Let's take now 5 bits, okay? Let's 0 1 1 1 0 1 0. Or let's talk about -13. So -13 is you have to take the positive 13 first, right? In a 5 bit, or you can even go with a 4 bit. 13 is 1 0 1 1. All right. So this is 1. So we're going to consider 5 bits. All right. 5 bits. So this is 13. So you have to flip it to get 1's complement of 15, of 13, sorry. So that is 0 1 0 0 1. Right? Then we need to add 1 to it. That becomes 1 1 0 0 1. So on the 5 bit, -13 is represented like this. Let's go back to the website, -13, and we set 5 bit. 1 0 0 1 1. Is it what it is? 1 0 0 1 1. Let's copy that to the PowerPoint. Let's take one more example, this time 6 bits. Okay, -22. -22 means we have to take positive 22 first. That means 0 0 0 1. That is 16 plus 6 we need. 0 1 1 0. All right. I'm considering whatever here 8 bits. We'll consider 8 bits. Okay. And 1's complement of this number is 1 1 1 0 1 one's complement, plus 1 you add to it, 0, carry 1, it's 1, 0, 1, 1, 1. So this is the negative 22 representation in our system. So let's go back and check it out. 22, we consider 8 bits, that is same as that. Alright, let's move this a little bit more. If you see here, 1110, 1110, 1111. Alright, so that is how negative numbers are represented. So you take any positive number, flip that to one's complement, then add 1. That's it. You get the negative number. All right. Thank you.